You'll notice the title of my presentation, Diversity in Science and Engineering Faculties, Preparing for the Great Crew Change. This is sort of the intersection between the two types of research that I do. I functionalize single-walled carbon nanotubes, which has applications in energy and solar cells and sensors. And also I research diversity in science and engineering. And so this term, the Great Crew Change, what is the Great Crew Change? And why do I use that term? This term is used by the petroleum industry to describe their anticipated workforce changes. And when I read that, I thought, this is a really nice term because it describes exactly what is happening to them now and what's going to happen in a lot of other science and engineering disciplines. They're seeing the departure of many senior scientists and engineers. Those are the baby boomers who are retiring or passing on. And they anticipate there's going to be a lot more in a very short time span. And secondly, they need to hire many replacements from younger scientists and engineers. And so they've envisioned this as a crew change where a lot of people leave and simultaneously a lot of people must come in. And they're calling it the Great Crew Change because it's not just a typical crew change that happens several times a day. So there's this term, and I saw that and I thought, I really like that. So I sort of stole it. And after that, other people have stolen it from me too. So I do think it's a great term. You might just remember that. The petroleum industry is just one example of a nationally important industry anticipating and experiencing these scientific workforce needs. And so who are going to be these younger scientists and engineers that are going to fill these positions? You. That's right. This is extremely important to you because our country is going to be relying on you to do this. You're going to have to step up and do this. The way that the petroleum industry analyzed it, the global industry demand will continue to grow, and these are their slides, which I stole. And you can see the projected annual growth. In the energy industry, they say our energy will be primarily from fossil fuels for the next 50 years. And yet, the oil and gas technical workforce age distribution is as given here. You can see a third of the technical workforce is over age 50. And so that's why they're anticipating a lot of retirements. This is the technical workforce. The professionals, 40% of the professionals will reach retirement age by 2010. And yet, there's a 70% decline in the geosciences enrollment. So you can see the problems that they're facing. They're anticipating a lot of departures and no one in the United States to take these positions. And so our research, like I said, my scientific research, we do research that is pertinent to science, to energy and the petroleum industry. And so we could see this happening and we could see their concerns. And I'm also very interested in the demographics of science and engineers, both among the faculty and among the students. As I see it, in order for a student to become part of the scientific workforce, they must pass through an educational institution, and the faculty are extremely important in helping the students pass through those scientific educational institutions successfully. So I was very interested in the relationship there. We knew that the demographics of the US population are changing due to underrepresented minority increases. We knew that the demographics of the US workforce are changing to include more women. And it's my belief that in order to become part of the scientific workforce, a person must pass through an educational institution almost always and get a degree, usually. And in order to maintain a constant or sufficient US scientific workforce, women and underrepresented minorities must be adequately represented in scientific education. So therefore, this is why we started doing this. We compared the representation of women and underrepresented minorities among faculty versus students in order to evaluate the capability of the United States to do this, to have a sufficient U.S. scientific workforce. So our surveys, and I'm going to tell you a lot of numbers today because these numbers are you and they are important to you, or should be, and you really need to know about them to help you make decisions in the future, to help guide your decisions and know what's happening around you. We looked at tenured and tenure-track faculty headcount disaggregated by race, ethnicity, by gender, and by rank. We got the data from department chairs because they were in the best position to know the characteristics of their own faculty. We looked at the top 50 departments in each discipline. Those were NSF-ranked departments according to research expenditures. And as Diana said in the introduction, we obtained populations instead of samples. It turns out this is very important because if you're going to tabulate the head count of underrepresented minorities, which you know are there in very tiny numbers, in particular underrepresented minority women. If the numbers are very tiny, and in some cases zero, if you tabulate the data for the top 50 departments and one is missing, and you come up with a number of zero, and you say there are zero, for example, black assistant professors in the top 50 chemistry departments. If you're missing one department, you can't say that because people will say, but what about the one that you're missing? There could be somebody there. So you really need to have all 50 in order to talk about these tiny numbers. And this was the first time anyone had done that. And since we did this, we were able to say, there's a zero here, a zero there. There's just one here, two there. And the head counts were that tiny in many cases. Now here's the table that we got for chemistry. This is the very first table we ever completed, and I don't expect you to be able to see the numbers. Okay, but maybe you can see the categories. And I'm showing this because I've agreed to give Diana this PowerPoint presentation, and she's going to post it, and you'll be able to pull this up and look at this presentation later. So notice the table. Here's the top 50 departments in chemistry. These are whites, blacks, Hispanics, Asians, Native Americans, and then the total. And within each race, you can see full professor, associate professor, assistant, total, full, associate, assistant, total. And where are the women? The women come after the decimal point. So right here, this is 1.001. That means there's one person and she's female, okay? And up here, there's just a 1. There's nothing after the decimal point. That means it's one person and he's a man. So the numbers tell you how many people there are, and then after the decimal point, you can see how many of those people are women. And the important things about this table are these two columns. You can see the two columns here. This is assistant professors for blacks, assistant professors for Native Americans, and the total in each case is 0. There were no black assistant professors in all of the top 50 chemistry departments combined, and that was astonishing. That was absolutely astonishing. And notice there were some who were in higher ranks, which meant they had been hired previously, but since one is normally in grade there for 7 years, that meant that none had been hired in 7 years. So why would people be hired earlier, but then not in the last 7 years? So this raised a lot of questions when this became public, and especially among the blacks and the Native Americans. You know, I was told, we sort of thought that was happening because we kept going to meetings and we didn't meet any young assistant professors, but we thought we were just missing them. This was the first time we ever actually saw data like this where somebody actually counted it. So the first thing we did is we went back and looked at the Ph.D.s. We looked at the Ph.D. attainment. And you can see here these lines are for blacks, and you can see that the numbers are increasing. It starts out at something like 16, a total of 16, and as you go over, it becomes 40s and 50s, and so this raised a question. Why is it that in the earlier years when the PhD attainment is just 16, it's possible to hire people, but in the later years when it's 50, why is no one being hired? So This created more questions, and the hiring has changed a little now, but not the way it should have. And as I see it, these are things that should concern you and questions you should be asking. And as Diana said, you should be stepping up and saying, I want to be the bump. I want to be the ones that are going to be hired. I want to make the change here. Now, I want to point out one other extremely important thing that is going on right now, and this is sort of a political question. Notice how I compared my faculty data to the Ph.D. attainment data. And it comes, these Ph.D. attainment data are from the National Science Foundation data. And these are Science and Engineering Doctorate Awards. So they're called SED data. And you might think that now this is a time in which these data are going to be extremely important to us. Since minorities are increasing as a percentage of the population, these data are essential. We absolutely must know how many of our Native Americans, blacks, and Hispanics are getting these degrees. But as it turns out, right now, there has been a move to suppress the release of these disaggregated data. And when I first heard about this, I did not believe it. I just could not believe it. And here, if you want to read about this, here this is. There are many people who are raising concerns and questioning this and fighting it. And so there are, right now, going on last week and next week, there are town hall meetings about this to discuss this. Should these data actually be released or not? The question is that whenever you release tiny numbers like this, these numbers are really tiny. When you release these tiny numbers, see there's a 1 here and a 2 there. If you release these tiny numbers, you can identify people. And so the rationale is, well, we want to protect minorities by not identifying them. But if you talk to minorities, they're saying, no, we want the data released. Release the data. So if these things concern you, you might want to email me, and I will forward your comments. But this is a sort of an argument that's going on right now, and it will affect you also, because you have to know what the numbers are in order to be able to plan future programs. It's going to be really hard for us to make any plans if we don't know what these numbers are. And there's my email address if you want to email me. It's DJ Nelson, just like my name, DJ Nelson, all one word, at ou.edu. And if you email me, I'll forward that. I'll forward what you write. Okay, so we did our pipeline analysis. These are the analyses. You're going to see a lot of tables in a minute, and if you don't understand everything on the table, don't worry, because she's going to post this someplace, right, Diana? And then you'll be able to come back and look at it. So I'm going to go through it, and I'm going to show you the sorts of analyses that can be done with these very important data, which must not be suppressed, okay? So you can do a pipeline source. You can look at, we often call the women and minorities moving through, and students moving through the pipeline from BS degrees to PhD degrees to faculty, sort of a pipeline. And so you can do a pipeline analysis. You can look at the pipeline source. You can look at the representation of women and minorities among BS degrees and PhD attainment. You can see whether or not there's sufficient same gender, same race mentors by comparing the representation of underrepresented groups among BS attainment versus in the faculty. You can see if there's a critical mass of women. For example, is there 15 to 30% of women among professors? You can see if there's a sufficient utilization of the hiring pool. Assistant professors are hired from recent PhDs, and so you can compare the representation of the underrepresented group among PhD attainment versus among assistant professors. And once you get the data out, you can compare and group the disciplines due to the patterns in the faculty data and the student data. And I will show you this. I will show you what the patterns are. And you can see the patterns for underrepresented minorities are similar to those for women, but the numbers and percentages are smaller, and so it's harder to discern. So we're going to look at the women, and then at the end I'll show you the tables, corresponding tables for minorities. And you'll be able to go online and look at those and compare them, and you'll actually see this. And so that does make it easier in a way to see that the trends that you see for women are the same as the trends for minorities across disciplines. And this is very important because a lot of times you'll, an organization that is trying to come up with a program to address the needs of women or minorities in science and engineering will come up with one grand program, and you're going to see why one grand program for all the different disciplines won't work. And also we don't have enough funds and resources and time to address all of the different disciplines. So it becomes very important to be able to group these, and we've grouped these into 3 different groups due to their similarities. And so that helps people who are designing programs. These are the results from our surveys. Over here, well, these are the groups. The orange lines put the disciplines into 3 groups, and you're going to see that at the end, how they can be grouped together. The numbers inside the red box are ours. Those are the Nelson Diversity Surveys. Those are the representation of women among faculty at the assistant, associate, and professor level, full professor, and all of them, and these are in 15 different disciplines, as you can see here. Okay? And we compare those against the National Science Foundation. These are the survey of earned doctorate data, which are about to be suppressed in the case of minorities. And these are for BS attainment. And so we can compare these, the student data versus our faculty data. The good news is that in most of the cases, the representation of women among BS recipients is increasing, except in some of the disciplines there are some declines. And you can compare the representation of women among BS recipients versus women among all professors to see if there are same gender role models. And you can see that in some cases there's more than a factor of 3 difference. And so this means that a lot of times women can take courses and never ever see a professor of the same gender, a female professor in that discipline. And the same things happen among minorities. You'll see this at the end. I'll show you. On the question of critical mass, some of the disciplines at the bottom have a critical mass. The ones at the top don't. A critical mass is generally regarded as 15 to 30%. And of course, for minority professors, there's not a critical mass at any point. You'll see that. And so what you're going to notice is that there's sort of an accumulation of deficiencies in these top disciplines. Okay? You may be noticing that already. And representation among Ph.D. recipients, all of them increase from the previous decade to the immediately past decade. This is the decade that 96 through 05, and this is 86 through 95, and you can see that there's an increase in the representation. And then this is the utilization. You can see the representation of women among Ph.D. recipients versus the representation of women among assistant professors. And inside the blue box, there's not a sufficient hiring pool utilization. So the numbers don't match. Here for electrical engineering, for the engineering disciplines, for physics and astronomy, the numbers for the representation of women among assistant professors, they're actually higher. So the utilization is higher. The utilization is very good in these disciplines of physics, astronomy, and engineering. And you can see this same sort of a pattern developing, and you see it the same also for minorities. If you look at the tables, the numbers aren't quite so large, but you can still see the same pattern. And so for engineering, physics, and astronomy, there's a good hiring pool utilization. In other words, a better match, a higher number for the representation among assistant professors than among recent Ph.D. attainment. And so in summary, if you look at all of the boxes where there were concerns, you can see that there's sort of more of an accumulation of concerns up here at the top. The way I envision it is that, the way I envision it is that the life sciences and social sciences, which are down at the bottom, are sort of on the same track as chemistry, math, and computer science. But chemistry, math, and computer science are sort of way behind on the same pathway. And then engineering, physics, and astronomy, they're on a different path where they have different problems. They have the source is much lower. They don't have such a good utilization. They don't have a good critical mass. The life sciences and social sciences, they have a higher source. They do have a critical mass, but they don't have a good utilization. Chemistry, math, and computer science have a really high source. They don't have a critical mass, and they don't have a good utilization. So there are really, you can see there are different concerns there. I remember being at a meeting a while back, and there were a lot of women there who work in areas on diversity. And one was a biologist, down here in this category. One was a chemical engineer, and they were talking. And the biologist was saying, well, the problem is we don't have a good utilization of our hiring pool. And she was right. But the chemical engineer thought about her utilization, and she said, no, that's not the problem. And she said, the problem is we don't have a critical mass, and we don't have a good enough source of students. And the biologist said, no, that's wrong. She said, we have a real good representation of women in our source, and we do have a critical mass. And they were arguing, and each one was thinking of their own data. And the thing is, I was standing there and I knew the data of both, and I realized they're both right. They're both right, but they're just thinking about their own disciplines. And that's actually what made me decide to put it together like this and make the point that you're not going to find one universal program that's going to serve all of these different groups. The best you're going to be able to do is to put it into 3 groups. Group the disciplines into these categories, and then make a different program for each one depending on the needs of those categories. Here are the patterns revealed again. Chemistry, math, and computer science each have a large pipeline source, but no critical mass among the faculty, and the leakiest pipeline. In other words, not a good utilization. Social sciences and life sciences each have a good source and critical mass, but a leaky pipeline. And 3, this is the one in the middle, engineering pipeline source is too small, and they don't have a critical mass, but they've got good utilization. Here are the summary slides for Hispanics, and you can see the boxes indicating concern. Once again, it's sort of accumulated at the top, and these slides will be available for you to go back and look at online. Here are the blacks. Again, the same areas of concern, once again coming back in chemistry, math, and computer science. And for Native Americans, every place is an area of concern. The numbers are just way too small for Native Americans across the board. These are underrepresented minority women. These are not percentages, they are head count. So if you're an underrepresented minority woman, this was in fiscal year 2002, you can really make a lot of change, okay? Just by stepping up, becoming a faculty member at one of the research universities. That was in 2002. Going to 2007, the numbers increased a little, but not so much. There's still a lot of room for improvement. And so, in answer, is academia prepared for the great crew change? No, we're not. We're not prepared. We need more faculty. We need more underrepresented minority faculty. We desperately need you. I mean, you must step up and help. The crew change will take place soon, so we must focus on underrepresented minorities at or close to employment. That's you. That's you. Established faculty are an important component of the underrepresented minority community because they can bring the students along. But underrepresented minority faculty often must worry about their own careers and welfare as well. Remember, when the plane is going down, put the oxygen mask on yourself before assisting the people around you. In other words, if you go on to become a faculty member, make certain that you get tenure. Okay? You have to think about yourself. You're not going to help anybody if you don't get tenure. Will you become one of those important underrepresented minority faculty? Will you help us? Are you going to help prepare for the great crew change? Let me give you this is my last slide. I'm just going to give you some pieces of advice that might help. For one, seek advice from many mentors when making an important decision. Okay? Don't just go to one person. When I was going through and I had to make an important decision, I would talk to about 12 different people. Ask opinions from 12 different people. And then do what you want to do. You think about what everybody has said, and then you think about what you want to do and make yourself happy, and you have to do what you want. You don't do what other people tell you to do unless it's something that you really agree with. Be a role model, ethical and transparent. You'll see a lot of political games. Don't get involved in them. Don't participate. Don't copy them. Be ethical and transparent, and you will be a good leader. Other people will want to emulate you. And mentor those who are junior to you, and you have to be patient. I was telling them last night, at a dinner, I was telling some of the people that I get a lot of emails from students, in 5th grade, 8th grade, 11th grade, saying, I have to do a report on a scientist, and I picked you. And so, can you answer the following questions? And you'll get questions like, where were you born? What made you be a scientist? What do you do? And then this last email I just got a couple of days ago, it said, age if living. You have to be patient. Sometimes you'll get some questions that are a little weird, but you just have to go along and expect those things. I just thought, isn't that sweet, and answered. It was a student in the 8th grade. So, and support and help those working for you. Working for change. Success may be delayed without you. We really do need you, so you're not going to be able to just sit back and watch. In some of these important struggles, we really need your voice, and we need you to step up and hopefully become one of those underrepresented minority faculty. Last, I'd like to acknowledge my funders and also thank Diana for inviting me here. And if anyone has any questions, you can please step up and see me afterwards. They told me that we don't have time or a microphone for you to ask questions right now. So.